development options, operations, and it all has to do how to engineer, define large machine learning, large AI projects. And we already had a talk at the deep learning meetup from, I will look it up for you, but how to integrate machine learning into continuous development, continuous integration. And that's the same thing. So you have all these data-centered tasks like data verification, data collections, all that what data scientists do. We define models and so on. And this is a very, on a temporal scale, this is a very low-paced process. Defining data sets, partitioning data sets, not mentioning annotation and so on, but also managing and maintaining data sets, training data models. This takes time. A model might take time to train about an hour to a day, a week, and a week. So this is a long time frame. But in continuous integration and development, you make a change in your code. You have a bug report. You change a line of code. You test it. You push it you deploy it, and it's live. And this may happen within minutes. A change is already deployed in the live system, in the online system. You can't do this in machine learning. So you have to find a solution how to integrate these long-paced processes into these fast-paced processes, and how to integrate all smoothly, how to add quality control and all this. And this is a very complicated task that has not been developed, that hasn't been seen many attention yet. And there is not this real process to this. And this spans over all talks. Everybody is talking about MLOps. This is a major issue. So now we're on the brink from AI was mostly this research-based topic, and now it's transitioning to the industry, to engineering, and how do we engineer AI projects? And everybody is kind of talking about this. This is a big issue. Yeah, there's this is this manual data process, this data extraction, preparation, model training, and so on. And then you also want to automate this pipeline. Manual is much too slow, much too expensive. You can think about how MLOps can contribute to a pipeline optimization, but how do you do this? This is not really well developed. You have to find strategies and so on. And then you have this continuous integration, continuous deployment pipelines, where you need kind of performance monitoring, model evaluation, automated model evaluation. You have to have holdout sets, model and data versioning and so on. This is a huge complex field. And then you want to have kind of like on the right side, you want to define processes or maturity models and so on. So it's a big issue, and this is MLOps is one of the topics that's currently hot trending, and it will be, I guess, over the next few years. We have to figure out how we do this on scale, how we can get quality into machine learning or AI projects, and how we can guarantee projects, quality in these projects. Yeah, as I said, just like everybody was talking about this. So determining the optimal AI architecture, also by this Lenovo talk. Kind of nice applied insight also by Miroslav Hulek. And kind of progressing, this is the machine data revolution. Was mentioned by Bill Briggs from Deloitte, but also by another one, which said kind of data is the new source code. And this kind of goes to it. And his main argument was that in this machine data revolution, in kind of not in near future, or in the one of the actors or one of the consumers of data will not be people anymore, or data scientists, but will be machines. Will be any machine agent that consumes data. So there will be agents, machine agents that provide data for other machine agents, and they will exchange data and consume data. So we have data dialogue, data pipelines and exchanges and so on. And that really makes sense from a technical perspective. This is not just kind of this industry influencer talk. This is really the machine learning pipelines are, we have raw data, like you crawl Twitter feeds, and then you apply machine learning to this. And what you get out of this is inference results, but on a large scale, it's again data. So you're kind of a compressed information space now, but then you can train the next model on this information space and transform it. This is always a projection from one data space to another data space to another data space. And information is compressed and compressed and compressed. And in the end, you make an inference result for a very high complex model use case. But in fact, you're piping data from one agent to another and just compressing it and merging it and fusing it and so on. And this is something that kind of goes hand in hand with MLOps. How do you guarantee this data? And also, when you have biases in data sets, you see the progression line. So you have bias in the one data set, and this progress. This is handed on to the next agent, and so on. Yeah, and this was kind of, I really like this data as the new source code. It kind of describes what I just explained. So you need new architectures, new process data architects, and it's all about the data. Okay, the next big thing. So we have MLOps, and edge computing was the other big issue in these kind of more than 12 talks that I watched. What's edge computing? So I've already explained it. So you move from the data center AI inference platform to the inference happens on the edges on the small computing devices, and this must not be doesn't need to be mobile phones. This can also be small embedded devices everywhere. And this is huge applications in a lot of sectors. It's the same in a lot of sectors. So mostly in infrastructure, so you can make everything connected. You can have all these he talked about traffic prioritization, so that you can, there's kind of you have an emergency vehicle driving to an emergency, and then there's something happening, like an accident on the road, and you can identify this accident, and you know where the emergency vehicle is because it's connected through 5G and so on, and then you can change the red lights to green lights and plan ahead. And yeah, that's kind of sci-fi, because in reality you have all these partitioned systems. But he was kind of trying to make a point. What's so great about edge computing in 5G? But that's one of the things. You can connect everything and make inference happen on the devices. You can detect objects, animals in forests, in national parks, count and just send back the detected information. You process data on the devices and send back the information to a server for data storage and high-level analysis and so on. And this is application scenarios and everything. And based on 5G, on the 5G standard, which allows kind of up to 1 million connections within 1 square kilometer, this is possible because you can have everything connected. You can even make your, like 20, 30 years ago, ways that you can have your refrigerator identify what's in the fridge. You can do this. And actually, this might happen sometime that your fridge is connected, and it doesn't take it's not really complicated to identify all these products, which is one of the things in retail. Yeah, everybody was talking about this. So also this guy, this is one of the talks that I really cannot recommend. This is ARM promotion, but even he was talking about 5G and ARM. These low-scale processors are fit to be supplied in edge computing scenarios. yeah, these were the biggest trends to sum it up: MLOps and edge computing in 5G.